Along the Texas Gulf Coast, it is completely normal to see family neighborhoods sitting right next to massive industrial facilities. When developers look to build new homes or schools on this land, the stakes for community health are extremely high. To evaluate a piece of property, developers start with what is called a Phase I environmental site assessment. Think of this as a high-level reconnaissance mission. Investigators pull historical records, old photographs, and city permits to see what the land used to be. They are looking to see if the property was ever a gas station, a dry cleaner, or a manufacturing plant. Those past uses are warning signs that toxic chemicals might have been spilled or buried on the site decades ago. But a paperwork review has a severe limitation. An old map can tell you a factory used to be there, but it cannot tell you if there is still a pocket of dangerous chemicals sitting in the dirt right now.
To guarantee that a site is actually safe for a new community, you have to stop looking at maps and start checking the actual ground. That is where the Phase II environmental site assessment comes in. This is a tactical, physical deployment into the field. Teams use heavy machinery to drill into the ground and extract physical samples of the soil and water. They are hunting for specific, invisible threats. The first targets are heavy metals, like lead and arsenic. These often hide right in the topsoil, where they pose a severe health risk to children playing in the yard. The second target is a group of chemicals called total petroleum hydrocarbons. These are essentially toxic grease and oil stains left behind by forgotten fuel spills. The third targets are volatile gases. Certain liquid chemicals trapped deep underground can slowly turn into invisible vapors, which can then seep up through the dirt and get trapped inside people's homes. Because these different toxins settle at different depths, investigators pull soil cores from several specific elevations, capturing dirt right at the surface layer, and then reaching down to grab the 1 to 2 foot sublayer. Those extracted cores are sealed under strict protocols and driven to an accredited laboratory, where scientists break them down to their exact chemical components. Finding the precise chemical makeup of those dirt layers is the only scientific way to map out the invisible minefield beneath our feet. Now, simply finding a chemical in the dirt does not automatically mean the property is a danger zone. Nature contains trace amounts of metals already. Texas uses the protective concentration level, or PCL, to define a safe site. This line is the maximum chemical limit for human health. Results below the line are safe, but toxicity exceeding the PCL standard triggers an immediate threat alert. That red line translates a spreadsheet of raw lab data into a clear, tactical decision for developers, ensuring they know exactly when a site requires a cleanup operation to protect the community. When that threshold is crossed, the team deploys a physical remediation strategy to neutralize the site. Engineers use heavy-duty solutions to solve the problem. That might mean using high-powered vacuums to suck dangerous vapors out of the Earth's pores, or physically excavating the contaminated dirt and hauling it away. Executing these operations guarantees that dangerous metals and toxic fuels are completely removed long before vulnerable neighborhoods are ever built over them. At Envirogyn, we treat environmental compliance as a strict discipline. The stakes for public health are simply too high to rely on guesswork or assumptions. Achieving true operational readiness means thoroughly testing the ground we stand on, ensuring safe, healthy spaces for future generations across the Gulf Coast.